Hey, 7th grade. So our learning target is I can calculate theoretical probability. So what is theoretical probability? The theoretical probability is the chance of what you think will happen. So we're not actually going to do an experiment. We're going to just think about what should happen. Best example ever is when you flip a coin. And people often say 50-50. What does that mean? That means it's a two-sided coin. You have a 1 out of 2 chance of getting heads. You have a 1 out of 2 chance of getting tails. 1 out of 2 percent-wise is 50%. So when they say 50-50, they really mean it's a 50% chance of heads, 50% chance of tails. So just like yesterday in our probability work, you're still going to have the same notation. What's the probability of the event? So the event maybe is heads. It's still a fraction. So we're still talking about your favorable outcomes over your total. Same thing. But what's different is we're going to really just be thinking about what should happen, kind of what you think should happen over what could happen. Okay, so same work as yesterday. We're going to convert that then into a percent as we did yesterday. So let's take a look at a real example. In example 1, you see these blocks here. And it's saying you randomly choose one of the letters shown. What is the theoretical probability? Again, no experiment happening. We're just talking about what should happen using good math. It's kind of like an educated guess in our work today. You maybe heard that expression in elementary school. What's the chance of choosing a vowel? So we were going to go ahead and write down the notation, probability, capital P of the event. The event is getting a vowel. So just a refresher on vowels. Vowel A, E, I, O, U, and sometimes Y. So how many total letters do we have here? We have 1, 2, 3, 4, 5, 6, 7 total. Denominator, 7. What's the chance that we get a vowel? Well, if I circle the vowels, E is a vowel, O is a vowel. Again, E is a vowel. So 3 vowels out of 7. That is our probability, but in my class, I'm going to ask you to convert to percent. So we're going to divide, 3 divided by 7, multiply by 100, or you can go T-table cross products on it, your choice. So 3 divided by 7 multiplied by 100. And I get 42.86% if we round to the hundredths like it's a money problem. Some of you maybe have just went right to 43% as well. I'm cool with either answer. I'll go ahead and highlight the 2 answers I will accept. I will accept the answer in green, or I'll accept the answer that you see on my screen in yellow, 42.86%, or I'll accept 43% chance of getting a vowel. So then you have a 4 out of 7 chance of getting a consonant. So that's our first example of theoretical probability of what we think should happen. Doesn't mean it's going to happen for sure if we were to grab blocks out of a bag. Example 2. The theoretical probability that you randomly choose a green marble from a bag is 3 out of 8. So they're actually telling us the probability right here. What's the probability of getting a green? They're saying you have a 3 out of 8 chance of getting a green. So that has been calculated for us. If we continue to read, it says that there are 40 marbles in a bag. How many are green? So instead of having 8 marbles in the bag, we're going to say, well, what if we had 40 marbles in the bag? How many would we expect to be green? So cross products, T-table cross products, or some of you might just be going straight mental math on that, which is cool with me. As we start to solve cross products there, we're going to end up with 15 green marbles. Go ahead and take a look at that. Make sure that you're coming up with that. We would get 15 out of 40 green marbles. Now, if this is going too fast, make sure you pause the video. If you have a sub today, you should ask very respectfully and politely if the sub will pause the video so you can catch up on your work. Okay, moving on. Let's go to you try 2. Now, in you try 2, we're going to use those same blocks from above. So I might actually drag them down on my screen so we can see them, but you shouldn't have any problem seeing all those blocks. So here are our blocks. It says in example 1, what is the theoretical probability of choosing an X? So our event name would be, what's the probability of getting the letter X out of those blocks? Well, we have 7 blocks to choose from. How many are the letter X? So as I'm looking at the blocks, I'm seeing that we only have really 1 block that has the letter X. So we have a 1 out of 7 chance. Now in my class, I ask you to go straight to percent on that. So we're going to go ahead and divide 1 division 7, 1 divided by 7. That's going to give you a decimal. We need to multiply by 100 to get percent. Gives us, in decimal form, 14.29%. You can go ahead and round that if you like, but we have a 14.29% chance that we're going to get the letter X when we draw a block. Okay, let's move on to example you try number 2. So it says the theoretical probability of spinning an odd number on a spinner is 0.6. The spinner has 10 sections. How many would be odd? So we have the probability of getting odd. It says 0.6 or 60%, which really just means 60 out of 100 or 6 out of 10. So kind of a trick question here. If you had 10 sections, how many would you expect to get an odd number? Well, we said right here, this is the equivalent of 6 out of 10. If you have 10 sections, then you're going to expect to get odd 6 times. Sort of a trick question there. So 6 out of 10 chance of getting an odd number based on what we think should happen. Okay, moving on. So let's talk about when an experiment is fair. An experiment is fair if all possible outcomes are equally likely. If we look at the example on the left, this definitely is fair. You have an equal chance of landing on a 1 or a 2. You can see the sections in 1 are in red and the sections in 2 are in blue on my screen. Definitely a fair game. Person number 1 has the same chance as person number 2. On the right-hand side, you can see that those are not equally spaced. So person number 1 has a better chance of winning than person number 2 and or person number 3. So a game is fair if every player has the same chance of winning. Make sure that you've noted that. It's already filled in for you there, but make sure that you have noted that as correct. Okay, meet me on the top of the next page. Top of the next page, example number 3. So let's go ahead and talk about a real game. So here's our game. You can see the spinner has 2 blues, 2 reds, 2 greens. You get 1 point when the spinner lands on blue or green. So you get 1 point if the spinner lands on blue or green. Your friend gets 1 point if the spinner lands on red. The first person to get 10 points wins the game. So let's go ahead and answer some questions. First of all, is this spinner fair? Well, if we go ahead and put some labels on this, we would say I win if I get blue or green. So this would be me, green, me, and me. So all the blue and green sections, I get the points. My friend wins if they land on red. So friend, friend. Is this spinner fair? No. The reason why it's not fair is I have a better chance of winning. So go ahead and write that. No, it's not fair. I have a better chance of winning, which sounds like an awesome game to me. I love winning. Go ahead and write that. Nope, I have a better chance of winning, so the game is not fair. We do not have an equal chance of winning. Is the game fair? So I score a point if I land on blue or green. My friend scores a point if they land on red. Is the game fair? No. It's the same as for the same reason. The spinner's not fair. So the game can't be fair. Predict the number of turns it will take you to win. Hint, use an equation. Well, let's go ahead and talk probabilities first. Let's talk about probability that I win. I'll say me. Let's say me. I have 6 sections up there, and I win if I land in blue or green. So 1, 2, 3, 4. 2 blues, 2 greens. I have a 4 to 6 chance of winning. The probability that my friend wins if they land on red, which is 2 out of the 6. So clearly I have a better chance of winning. So using an equation here to figure out how many times it would take me to win would be this. If I'm going to need 10 points, I'm going to say X is the number of times to win. I have a 4 to 6 chance of winning every time I play. So 4 to 6, how many times would I need to win to get 10 points? This is the equation we'll solve here in blue. I'll go ahead and highlight that. You have a 4 to 6 chance of winning. How many times would I need to play so I get 10 points? There's your equation. We're going to go ahead and defraction this. So when we go to solve this, we're going to go ahead and multiply by 6 first. Copy, paste. Okay? And then we're going to solve. We're going to have 4x equals 60. Hand method kicks in, so we're going to divide by 4, copy, paste. And so we get x equals 15. So you have really 15. We would predict the number of times. So it says, what is the number of times you expect to play until you win? Really 15 times, using some good algebra there. Go ahead and pause the video if you are confused at this point, and go ahead and look at that again. Okay, so moving on. What if? In the what if box, what if in example 3 you get 1 point when the spinner lands on blue or green? Your friend gets 1 point when the spinner lands on red or blue. The first person to 5 points wins. Is this game fair? So the probability that you win if you get a blue or a green. So that's out of 6 times, how many blues and greens? Well, we have 2 blues and 2 greens, so you have a 4 out of 6 chance. This is you. How does that compare to your friend? Well, your friend has a probability of winning if the friend lands on red or blue. You have 2 reds and 2 blues, so we would say red or blue. So again, that's a 4 out of 6 chance. The first person to 5 points wins. Is this game fair? Yes. You each have a 4 to 6 probability, so you have the same chance of winning. For sure, it's fair. So your answer should be yes, but you should be providing some good solid math there to support your answer. So let's talk about what's called an impossible event. An impossible event really means that you have a probability of 0. So you maybe have heard of these in situations before where even your friends are like, that's impossible. Well, that's really what it means. It means it cannot happen. A probability of 0 means there's no possible way it can happen. So an example would be is if we look up at that spinner on the top here and I say, what's the probability that we land in yellow? You would say, well, 0. The probability is 0 or 0% because we don't even have yellow on the spinner. You couldn't win. So on the opposite end of the spectrum is called what's the probability of landing on 1? It means it's going to happen for sure. So going up to that same spinner, when I said the probability of 0 is landing on yellow, a probability of 1 would be that we're going to land on either blue, green, or red. That will happen for sure, because if we land on a line, we would have to spin again. So 100% chance, probability of 1 would mean we are going to land on blue, green, or red. So let's go ahead and talk about this next example. What is the probability that all of my students go to Skyview? Every student I have, what's the chance that they go to Skyview? We would say yes, for sure they go to Skyview because they're in my class. So that's a probability of 1, which is the same as 100%. That all of my students are Skyview students. The opposite situation of that is really, what is the probability that all of my students are 12 years old? That's definitely not true because I know I have some 12-year-olds, I have some 13-year-olds, and I think I even have one 11-year-old. So what's the probability that all of my students are 12 years old? No, not true. Some of my students are 12 years old. Most of my students are 12 years old. But the key is, are all of my students 12 years old? No. So for today's lesson, we talked about theoretical probability. We're really talking about what we think is going to happen. So theoretical probability is what you think is going to happen. It doesn't mean when you actually go do the experiment, it's going to happen for sure. It goes back to the idea of, if I were to flip a coin 10 times, I would expect that the probability of getting heads is 5 out of 10. 50%. That doesn't mean for sure when I go to flip a coin 10 times that absolutely for sure in the experiment I'm going to get 5 out of 10 heads. It just means mathematically speaking that's what should happen. That doesn't guarantee it's going to happen. That is why casinos are in business. All right, your homework for today is to finish page 7 and 8. I do expect percents on all of your work for tonight. Have a fabulous night, 7th grade.